So I figure I probably better go over end behaviors a little bit more here. End behaviors are whenever you're talking about a graph, if you have a shape of a graph here, end behaviors are where are your graphs, where are your arrows pointing at the left and on the right. In this case, in this picture, on the left, your y values are pointing up, so you would say that y would be approaching positive infinity. On the right, this is also pointing up, so here you'd say y is approaching positive infinity also. If you have a graph that may look something like this, well, then in this case, on the left, you're going to say y is approaching positive infinity. But on the right, this is y is approaching negative infinity. So what we're trying to do here is trying to get this so you can determine your end behaviors. Now, instead of saying y, what you want to say is f of x. So don't get all rattled just because it says f of x instead. So we're going to put f of x approaches positive infinity. Now, whenever we talk about our left and our right parts of your graph, you always have left and right part. The left or the right part is x approaches positive infinity, and then the left part is where x approaches negative infinity. So I showed you this table before and said really the only things you need to know are when you write out your end behaviors, f of x approaches, and then I put a blank underneath here because this is the only part that changes, this value right here. This as x approaches negative infinity, which is your left side, that means x is going to the left. You need to state what your y is doing, going up or going down. That stays the same. And then here you have f of x approaches blank as x approaches positive infinity. This is the right side, so what's your y doing? Is it pointing up or is it pointing down? That never changes. So if we talk about our end behaviors, we'll come back to this. You're always going to write it as f of x approaches a blank as x approaches negative infinity. This is the left side, okay, because x goes that way. So that's the left. And then on the right side, you still have f of x approaches blank as x approaches positive infinity. So you're going to say this will be on the right. Now, we need to look at the left side and the right side of your graph. So if you look at the left side, okay, what is your y value doing? Well, this is pointing down, which means that your y is approaching a negative infinity. So all you do is just put negative infinity in for that blank. On the other side, your right side, you have this arrow pointing down once again, so this is going to negative infinity also. So if you just remember what's in the pink here, this is your template, is what we'll call your template. You can write out your template for every single problem, and then all you have to fill in is what your y value is doing. So if we go to B and C, you could write out your end behaviors. Put your template here, put a blank as x approaches negative infinity. Then we can also say f of x approaches blank as x approaches positive infinity. And then down here we're going to have f of x approaches blank as x approaches negative infinity. That's your left side, right? X goes to negative infinity on the left. And then f of x approaches blank as x approaches positive infinity. So that is the same, okay? It's the same no matter what. All you have to do is then just look at the left and right side of your graph. So here, let's look at the left. Is your arrow pointing down or pointing up? Down. That's right, it's pointing down, so you'd say it's going to negative infinity. Here on the right side, is this pointing up or down? Up. That's correct, so it's going to be going to positive infinity. Ta-da! You're done with your end behavior. Let's go down the bottom. Left side. That's pointing up, Mr. Parr. Positive infinity. On the right, that's going up as well. So once you get your template in there, man, that's just a piece of cake. Looking at pointing up, goes positive infinity, pointing up, positive infinity, pointing down, negative. Whew. That's the toughest part about these problems. Okay, the other part, you have to determine whether you have an odd or even degree, and then you have to state your number of real zeros. Stating your number of real zeros, we have done this back in chapter 5 when we were trying to determine zeros of a polynomial, of a quadratic. Okay, your number of zeros is just how many times your graph touches your x-axis. So you just count how many times your graph touches your x-axis and state the number. Determining whether you have an even or odd degree, it's easy to look at this picture. For an even degree polynomial, your arrows are either pointing both down or both up. These are going in the same direction, your arrows are. For odd degrees, these are going in opposite direction. Okay, opposite direction. I don't know, I guess maybe a way to remember, same has 4 letters, even has 4 letters. That may be a way that you can remember. Odd starts with an O, opposite starts with an O, so you may be able to remember that as well when you're trying to figure out whether you have an even or odd. So if you look at example 4a here, to determine your even or odd, well, these are going in the same direction, so that means you're going to have an even function. And then you want to determine how many zeros. Well, how many times does the graph cross this x-axis? How about none? You don't have any zeros. Ta-da! Boy, that was nice and cake for the rest of that. The end behavior is the toughest part. Let's look at B and C. Let's figure out even or odd. Okay, well, they're, in this case for B, they're going in opposite directions. Opposite starts with an O, so you can say that's odd. And how many times does this cross your x-axis? Looks like just once. So you're going to have 1 real zero. You may have imaginary zeros, but you only have 1 real zero. Down here at the bottom, these are going in the same direction. So same has 4 letters, even has 4 letters. And then how many zeros do you have? Well, you have 1 here and 1 here. So we're going to say you have 2 zeros. So I hope that's a good little finisher-upper reminder thingy for how to do the last couple problems. Just don't forget your template that you have to follow along, and then just plug in your plus infinity or negative infinity. Hopefully that will help you out with your homework.